Wanted to work through a problem that involves velocity transforms that are relativistic velocity transforms that involve speeds, velocities close to nearby the speed of light. For this case, we can't use the more familiar, more common sense Galilean transformations for transforming velocities between reference frames. In this case, we got to use the more complicated, less familiar Lorentz transforms for transforming velocities between different reference frames. So in this particular problem, we're asked to imagine that a Earthling and Austin Powers in a spacecraft both observe Dr. Evil in his spacecraft. And we're told that from the Earthling's frame of reference, Austin Powers in his spacecraft is traveling at 0.8 of the speed of light, and that Dr. Evil is traveling at several speeds, 0.9 of the speed of light, firstly, then 0.7 of the speed of light, secondly, and then changing direction, minus 0.8 of the speed of light. So that's the Earthling looking at the motion of Austin Powers, looking at the motion of Dr. Evil, and we're told the velocities of Dr. Evil and Austin Powers from the Earthling's perspective. What we've got to calculate is the motion of Dr. Evil from Austin Powers' perspective. So I'm going to start the problem by annotating this sketch a little bit. So over here on the left in blue, this is Austin Powers spacecraft. Over here on the right in red, this is Dr. Evil's spacecraft. And here is Earth and the Earthlings in the center in green. So there's two frames of reference I want to sketch. There's the Earthling frame of reference. I'm going to call that the unprimed frame of reference. I'm going to label the position coordinate X and the time coordinate T. Then there's Austin's frame of reference. I'm going to call that the prime frame of reference. I'm going to label the position coordinate X prime, the time coordinate T prime. Now we're told in the problem that Austin and his spaceship are observed to be moving towards the right at a speed of 0.8 times the speed of light. So let me add that velocity here. This is the relative velocity of Austin Powers reference frame with respect to the Earthling reference frame, and it's 0.8 times the speed of light. The Earthling reference frame is also moving with respect to Austin's reference frame at 0.8 times the speed of light in the left direction. I'm just indicating here the motion of Austin's reference frame with respect to the Earth reference frame. The other thing that we're told in the problem is from the Earthling reference frame perspective, the motion of Dr. Evil and his spacecraft. And we're told that initially he's traveling at 0.9 C towards the right, then 0.7 C towards the right, and then finally he's traveling at minus 0.8 C. That minus sign means towards the left. He's reversed his direction. And what we've got to do in this problem is calculate the corresponding velocities seen by Austin Powers in his reference frame, in his spaceship. I'm going to call them Vx prime. They're the velocities of Dr. Evil in the prime reference frame, knowing the velocities of Dr. Evil in the unprimed reference frame. Okay, so now we can go ahead with the calculation of the speeds, the velocities that Austin Powers see Dr. Evil traveling at, based on the speeds or velocities that the Earthling sees Dr. Evil traveling at. And for this, we're going to use the Lorentz velocity transformation that works for high speeds, that works for speeds that are the scale of the speed of light. And the Lorentz transformation says that the speed, that velocity that Austin will see Dr. Evil traveling at, we call that Vx prime, is going to be the speed that the Earthling sees Dr. Evil traveling at, we call that Vx, less the speed that Austin is traveling at with respect to the Earthling, that's the VR, divided by this new factor involved in the Lorentz transformation. And that factor is 1 minus the product of the two speeds on the right-hand side here. Dr. Evil's speed in Earthling frame and Austin's speed in the Earthling frame. And that's divided by c squared. And so that's the new piece in the Lorentz transformations. So let's go ahead and fill in the numbers. In the numerator, first of all, we've got Dr. Evil's speed in the Earthling reference frame. And then we've got Austin Power's speed in the Earthling reference frame. So that's 0.9c minus 0.8c. And then in the denominator, we've got 1 minus this new piece that vanishes if the speeds are small compared to the speed of light. And that new piece involves the product of Vx and Vr, so 0.9 times 0.8 divided by c squared. But the Vx is 0.9c, the Vr is 0.98c. So the c's actually all cancel out. So this just becomes a number that we can subtract from this number 1 over here. And if we carry out that calculation, I got 0.36, positive 0.36. And so Austin is seeing Dr. Evil travel towards the right at just over a third of the speed of light. Okay, so now we can do the calculation for the second speed that the Earthlings observed Dr. Evil to travel at. This is the 0.7 times the speed of light. So what does Austin Powers see the second speed for Dr. Evil to be? Again, we can use exactly the same Lorentz transform formula. I won't write it down again. We're just going to be plugging in different numbers. So the new number is that now Dr. Evil is traveling at 0.7 of the speed of light. And so in the numerator, there's 0.7 of the speed of light minus the speed that Austin Powers is traveling at in the Earthling reference frame. That's not changed, so it's still 0.8 times the speed of light. And then in the denominator, this new Lorentz transformation term is going to be 1 minus now 0.7, not 0.9, times 0.8, the product of Dr. Evil speed and Austin speed. And if you carry out this calculation, you're going to get a minus sign, and you're going to get a value that is already calculated at 0.23 times the speed of light. And so this is the new velocity that Austin is seeing Dr. Evil traveling at. Finally, we can do the same calculation again for the final velocity that Dr. Evil is traveling at. This time he's reversed direction and he's traveling at 0.8 times the speed of light towards the left. So we're going to plug in this new speed. And so the numerator becomes minus 0.8c minus another 0.8c. Those are the speeds of Austin's motion, related to Austin's motion and Dr. Evil's motion. And then the denominator is going to be 1 minus, and be careful with the minus signs here. This is minus 0.8c. That's Dr. Evil's speed, plus 0.8c. That's Austin Powers speed. And if you carry out that calculation, I already did that, I got minus 0.98 times the speed of light. 98% of the speed of light. So let's just take a moment and see if we can understand the results of our calculations here, because they're quite interesting. There are these three numbers here, which are the three speeds of velocities that Austin sees Dr. Evil traveling at, based on the three speeds up here that the Earthling saw Austin traveling at. So when we look at the three speeds over here on the bottom right, let's think about what they would have been if there wasn't a relativistic velocity transform. It was just the old-fashioned classical Galilean transform. In the first example, when Dr. Evil's traveling at 90% of the speed of light towards the right, and Austin is traveling at 80% of the speed of light towards the right, if it wasn't for the Lorentz transformation, then Austin would see Dr. Evil traveling at 10% of the speed of light, because that's how much faster his speed was than Austin's speed in the Earthling reference frame. So this numerator here is 10% of the speed of light, 0.1 c. But because of the relativistic velocity transformations, Austin actually sees Dr. Evil traveling towards the right at faster than that. It's actually more than a third of the speed of light. So that's an interesting point there. Another really interesting one, I'll jump down to the third example here. In this case, Austin was traveling towards the right at 0.8 times the speed of light. Dr. Evil was traveling towards the left at 0.8 times the speed of light. If it wasn't for the relativistic velocity transform, if it was just that old-fashioned Galilean classical velocity transform, then Dr. Evil would be approaching Austin at 1.6 times the speed of light. The relative velocity of Dr. Evil would be minus 1.6 times the speed of light. But in relativity, the speed of light is an upper limit on speeds, and nothing can travel faster than that. And so we see that when we do the relativistic velocity transform, that Dr. Evil isn't traveling towards Austin at 1.6 times the speed of light. He's just traveling towards Austin at 98% of the speed of light. So he doesn't break the speed limit, nature's speed limit on the speed of light.